Hello students, in the last lecture we understood how to solve the numericals of resistance and Ohm's law, and now we'll study about the circuits, various circuits that are involved, and how those circuits are made, and what are the various combination of the loads or the resistance or the various electrical equipments. So what is electric circuit? It is a continuous conducting path consisting of wires, other resistance like bulbs, etc., and a switch between the terminals of a cell or a battery along which electric current flows. ठीक है. अब if we talk about figure, and what will happen, it has a source battery of suppose V voltage, and there is a switch, and the various resistance like bulb and other resistance, and the current that flows through the circuit is called as I once the switch is turned on. So we know that if we have a bulb and a fan in a room, as soon we switch on the fan, soon we switch on the light, it glows, the bulb glows, and the fan starts running. So there are various combination in which they are added, and the various combination that we are talking about is one is series combination and the other is parallel combination. So if we talk about series combination, then this series combination is the combination in which the various electrical equipments that are referred to as load, or we say that these are electrical equipments which have some resistance. These resistance are added lengthwise. So lengthwise means one ends to the starting of others. So if this is the first resistance, then this resistance end will be connected with the initial point of the other resistance. So we can say that two resistance connected end to end consecutively, two or more resistance. Here I have made two resistance. It can be 3, it can be 4, it can be n number of resistance. Now because there is only one arm, and we can connect a battery from this and from this terminals. We know that battery creates potential difference. So if potential difference is maintained across these two terminals, what will happen? The current will start flowing, and we can see that the current moving from this to this resistance, that will be same. And so a basic idea about series combination is that in series combination the current remains same through all the resistances. And for your knowledge, that we'll see in the derivation as well, the overall resistance of the circuits get increased. So you can say that the individual resistance is always less than the resultant resistance. And what is resultant resistance? It is like resultant force. I'll define later. So here the other combination is parallel combination. So you can see that there are two terminals, that is through points, that is A and B, and in between A and B if we connect battery, then you can see that in between A and B various resistance are lying. One individual resistance between A and B here, one individual resistance between A and B here, and similarly we can make a resistance from here, or we can make a resistance from here. So every resistance, the potential difference is same. So two or more resistance connected between between two same points. So because they are connected between same points, across individual resistance the voltage remains same. And also in the case of parallel resistance, what happens? The voltage is same, but the current gets distributed, and overall resistance, that the new resistance formed through this combination, has a value that is lower than the individual resistance. Let us go with the derivation. Suppose we talk about the series combination and the resultant resistance. So the first figure that we are talking about is here the supply voltage is V, and the various other resistance that are combined in the circuit are R1, R2, R3 and Rn. Now this R1, R2, R3, Rn are connected end to end. Such combination is called as series combination. Now if this V is the voltage, and the current that is drawing from this battery source is I. Now this I will go with along with this R1, R2, R3 and Rn. So this I is same. But if this I goes through this R1, then the product becomes IR1. From the Ohm's law we can see that there is some potential difference maintained across this resistance. Similarly, when this I goes through this R2, there is some potential difference maintained across this resistance, or you can say there is some voltage drop here, there is some voltage drop here, and there is some voltage drop here till here. Now you can see that every individual resistance is causing the voltage drop. So overall voltage drop that we received, or the potential difference that is maintained across every resistance, has some equal to the supply voltage. So the whatever the supply voltage is, this V1, V2, V3 and Vn will combine to give the same result. The current is same, but the voltage is being changed across every resistances, and the sum of the potential difference is equal to the supply voltage. If we want to remove these R1, R2, R3 and Rn by a single resistance, that could cause the same, that could draw the same amount of current from this source voltage V, as we understood in the resultant force, that the single force that could cause the same effect as that of the n number of forces. So here the single resistance that can draw the same current through the same through the supply voltage V. So here we have taken as RS. So if we know what is RS and we know what is V, then we can easily find what is the net current that is flowing through the circuit. So here in the resistance we can write like current remains same through every resistance, voltage drop in there is there across each resistance, whose sum is equal to the voltage or supply voltage. Sum of potential difference across resistance is equal to the supply voltage. So from the figure we can write V is equal to V1 plus V2 plus V3 plus dot dot Vn. So here we have written from figure, the first equation becomes V1 plus V2 plus V3 and so on till Vn. And by applying Ohm's law we can write, we know V is equal to IR and current is same in all the resistance. So from we can write the supply voltage V and the supply current I we can find from this. If we know the RS, we can get the what exactly is the current flowing through all the resistances, because here we don't know what is V1, V2, V3 and Vn until we know the current. So by making one single resistance we can know what is the actual amount of current flowing through the circuit. So it becomes V is equal to IRS, and once we have I, we can determine what is the individual voltage drop across each resistance. So if we know I, then IR1 is the first drop, IR2 is the second drop. So we can write like this, that V is equal to IRS, V1 is equal to IR1, V2 is equal to IR2 and V3 is equal to IR3 and so on. Vn is equal to IRn. Now we'll put this V, V1, V2, V3 and Vn into the original equation and we'll get the result. So IRS is equal to IR1 plus IR2 plus IR3 plus IRn. We take I common at the right hand side, the I will get removed and we'll get RS is equal to R1 plus R2 plus R3 and so on till Rn. Thus the equivalent resistance or the resultant resistance of series combination increases, and that is always greater than that of the individual resistance. And because the resistance increases, so you should remember that because the resistance is increasing, the current flowing through the circuit is always lesser, because the actual current that flows depend on the combined effective resistance that is working in the circuit. And the example of such combination is the fancy lights that we use during the Diwali. So if you have seen that if one bulb get disturbed, the entire combination of that particular array gets disturbed. And now the second combination is parallel combination. In parallel combination, if you see, there are two nodes, one node is A, one node is B, and between these two nodes the voltage that we have applied is V, or you can say the supply voltage battery is of V. Now between these two terminals the voltage is V, and we have connected various resistance R1, R2, R3 and Rn, and all the resistance will have the same potential difference. So here also the supply voltage is V, here also the supply voltage is V, here also V and here also V. Earlier in the case of series combination, the voltage was different across every resistance, but the current was same. Here you can see if the I is the current that is drawn through the supply voltage, or you can see I is the original supply current, then this I gets divided into the various currents, that is I1, I2, I3 and IN across individual arms. This arm is of resistance R1, so the current we have taken as I1. If this arm is at very high resistance, because the supply voltage is V, so it will draw less current as per Ohm's law. ठीक है, जब रेजिस्टेंस ज़्यादा होगा तो करंट कम हो जाएगा, रेजिस्टेंस कम होगा तो करंट ज़्यादा हो जाएगी. नाउ बिकॉज दिस R1, R2, R3 and Rn have same potential difference, now the current that is flowing through these R1, R2, R3 and Rn will depend upon the resistance. Higher the resistance, lower the current, lower the resistance, higher the current. If we replace this R1, R2, R3 and Rn by a single equivalent resistance Rp, or you can say resultant resistance Rp, then we can easily find what is the net current flowing through the circuit. Once we get the net current flowing through the circuit, we can also find the various current flowing through these circuitry, and if we get the sum of these currents, that will be equal to this supply current I, or you can say the source current I. So in this parallel combination, the potential difference across each resistance is same as that of the supply voltage, and currents get divided into each resistance. Higher resistance have lower current and vice versa to keep the voltage source balance, that is by the Ohm's law, and sum of individual current is equal to the source current. Thus we can write total current I is equal to I1 plus I2 plus I3 so on till IN, and as per Ohm's law V is equal to IR, we can calculate I is equal to V upon R. So if I is equal to V upon R, from here we can find the current I is equal to V upon Rp, and here I1 is equal to V upon R1, I2 is equal to V upon R2. So what we have done, we have find the value of I1, I2, I3 and IN, and we'll put this in this original equation. Once we put the value of I2, I3 and IN in this equation, we can get what is the net resultant resistance or equivalent resistance. So putting values in the equation, V upon Rp is equal to V upon R1, V upon R2, V upon R3 and V upon R1, we can get V upon Rp is equal to V, taking common, 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 and 1 upon R3 plus 1 upon R1. So the formula that we get for parallel combination is 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus 1 upon R1. And whenever we find this kind of resistance, so after finding this 1 upon R1, 1 upon R2 plus 1 upon R3, we try to find the Rp. So we have to change that denominator into numerator, so we do the inverse. So the overall resistance becomes less. So in parallel combination, the net resistance is always lesser than the individual. So if we talk about the example of where we use parallel combination, so in our home we always use parallel combination. So the various fridge, TVs, bulbs and fans that operates in our home acts in parallel combination, and the potential difference is maintained from the pole by the live wire and the neutral wire. And if we talk about inverter, we have a battery there. From the battery, the inverter changes the alternating current into direct current. So direct current into alternating current, that is used in a home. What is alternating, what is direct current, we will study later. So why we use parallel combination in a home, let us see that. If we talk about series combination, suppose various equipments are arranged in series, but if some equipment gets faulty, suppose this equipment get faulty. Now if this equipment get faulty, this circuit will lead into open circuit and the supply to the other equipments gets hampered or that get affected. So because of one faulty equipment, the other equipment will stop working. Also in the case of series combination, because the resistance become very high, so the current that is drawn to the supply voltage V is less, and sometimes that less current going through the resistance would cause the which could cause the that electrical equipment to not work properly, because अगर करंट कम मिलेगा तो हो सकता है कि वो अपनी जितना करंट उस इक्विपमेंट को चाहिए that is not sufficient and that equipment will not work properly. So also the second thing is, because there is individual voltage drop that is occurring to every point, R1 पे कुछ वोल्टेज ड्रॉप हो गया, R2 पे कुछ हो गया, R3 पे, तो व्हाट मे रिजल्ट इज दैट जो इक्विपमेंट लास्ट में है, द इक्विपमेंट दैट आर कनेक्टेड एट द लास्ट विल नॉट गेट प्रॉपर करेंट, प्रॉपर सॉरी the equipment will not get proper voltage, and that improper voltage or less voltage can lead to the means disturbing that equipment, or that equipment may get faulty. So to avoid such things, we combine various resistance in parallel, because in parallel combination every equipment will have same potential difference. Every equipment will have same potential difference, so it can draw whatever current it requires for its operation. Because voltage is same, their resistance is fixed, so they can draw individual current through them and they can run smoothly. Also, if one equipment, suppose this R1, R2, R3 and Rn is there, if any of the equipment gets faulty, so if this, suppose this equipment get faulty, this circuit will act as open circuit, but this open circuit will not hamper the other three resistance. All the other three resistance will keep on working. So parallel combination, the overall resistance decreases. Also, every resistance could have the proper amount of current, because the potential difference across every resistance is same. And if one equipment is getting faulty, the other equipments keep on working. In the next lecture, we'll study numericals. And numericals, I'll give you a brief hint. Whenever you see circuit, try to draw a source current. Wherever the source current is same, all the circuits are in series combination, and wherever the source current distributes or divides along the various path, those paths where it is being distributed are in parallel. Once I'll solve the numerical, I'll tell you that in detail. Whatever I taught today, just go with the derivation and learn the formula. What is the equivalent resistance in series and parallel combination? Till then, thank you, and we'll discuss in the conference that is on Monday. Thank you.